Hello friends, welcome to TechnoBytes. So in this video we are going to learn about three things. That is, first one is coroutine cancellation, second one is run blocking, and third one is async and await of functions. So let's see first the coroutine cancellation. Basically, coroutine cancellation is coroutines can be cancelled automatically or manually. We can cancel a coroutine by manually. So let's see. Uh, we have already seen this global scope dot launch to launch a coroutine, and we have already written some code here to demonstrate how the coroutine works, but we haven't given attention to the what if this coroutine block returns something. So let's try if it's returns something. Let's hover on this a, and it is showing at a equal to job. So global scope dot launch on any coroutine scope can return a job that we can use that job parameter to cancel the coroutine. Basically, to demonstrate this one, let me do one thing here. I'll make one with 5000 times, and not 5000, repeat only 5 times. I will provide a delay of 1000, and then we'll put some block and coroutine running. Okay, so this block will run up to 5 times and with a second delay of 1 seconds each, and it will print coroutine is running. Okay, so this coroutine is expected to run 5 times. So let's try running it and open the logcat. And here is it is okay. It printed 5 times, 1 2 3 4 5. So it has repeated 5 times and with a 1 second of delay. So it is working as expected. Now I will launch another coroutine, global scope dot launch, and use this job dot cancel here. We can also pass a cancellation exception here, but we are not going to talk about that right now. So it will cancel the job after specific delay. Let's say 3 seconds of delay. Do one thing, let's rearrange this one, because the 1 second will go on and we will not be aware of that. And now relaunch application to see the output in the logcat. So I am opening the logcat. So yes, it ran it so it ran up for 3 times for 3 seconds, and then it got cancelled. At first execution came to here, it started repeating and with a delay of 1 seconds. So it started 1 2 3, and after 3 seconds this coroutine was this coroutine has triggered this command job.cancel, and this job has been cancelled and the further execution did not happen. So that is the advantage of cancelling the coroutine manually. We can cancel the coroutines manually, and if we want we can prevent the further execution of the program. So this is how we can cancel the coroutine. Well, it was very simple at this place, but it must not be simple at all the other places. Like, let's say here in the global scope dot launch, we might have put some heavy operation like some recursive function call or some heavy network call to get the data, and the call is going and going again and again. And as the coroutine is busy with managing with performing this operation, there might be a case that another coroutine or from somewhere this job has been cancelled, but still as it is busy in its own operation, there might be chances that it is not again looking again and again if the job still exists. So for that, maybe further execution for up to certain limit can happen. So to avoid that, we have one keyword. We can just put a if condition here, and we can just put is available, is active, sorry, is active. So this active is active checks if the if this coroutine or if the job is still active, and then only it executes the execution, so that further execution will not happen. It will check every time that if the job still exists, and it will not make un unpredicted outputs, so that we can make some intended program as we want. Now let's move towards another topic, that is run blocking. What is run blocking? Run blocking is one function which which is basically a coroutine block, but it freezes the UI while executing the block. Like in the coroutines, in the other scope like this global scope dot launch and another scopes, this block creates a separate thread and it does its work in that, freeing the main UI. But run blocking does every work on the main thread itself, blocking the main UI. So let's see how it works. To demonstrate this one, let me again print the names of the threads. Log t running from outside run blocking, and we'll put the thread name here, thread dot current thread dot name, and here we'll start run blocking. As you can see here, this colon coroutine. So this is also one of the coroutine, but it freezes the UI. It runs everything on the main thread. So we can just copy this one and paste here, running from inside run blocking, and let's see if we get similar thread names or not. Let me clear the logcat and let again run the application. Okay, here we got the output in the logcat, that is running from outside run blocking, that is running on main thread, running from inside run blocking, that is also running on main thread. So everything which we put in the run blocking will actually be executed on the main thread itself. So you might get confused by asking yourself a question that if I have the coroutine which can perform the task in the thread and not put the pressure on the main thread, then why there is run blocking? There might be some cases where run blocking is useful, and we had to execute some operations in the main thread itself, but with the coroutine, with the help of coroutines. So that's where run blocking come to use. Basically, this run blocking provides coroutine behavior in the main thread. Now let's run towards our third topics, that is async and await functions. Before going to explain async and await function, let me do one thing first. Global scope dot launch, and let's say we have two suspend functions. Suspend fun get data one, which will return a string, and let's simulate it as we are making a network call which takes 3 seconds, and after that it will return some data 1. We'll make a similar function with the data 2. Okay, here to these functions, and we are calling these functions from this coroutine. and we are logging the results for that from call 1, and we'll append it here, call it here get data 1, and the same way to for another function as well. Now we'll also measure the time required for these two calls simultaneously, where time equal to measure time millis, and inside this block we'll move both of these network calls, simulated network calls, and at the end we are logging the total time taken and plus this time will be in milliseconds. So let's try running our app and see how much time it takes. Okay, it is the time taken. It once we have got the one call data 1, call to data 2, and the total time taken is near about 6 seconds, because both calls are taking near about 3 seconds, 3 seconds. So they both add up as they are running in the same coroutine. That's why we are getting them at simultaneously, and the time taken is 6 seconds. So this network call is being affected. It is not getting run until this network call gets back with its data. So that is some maybe we can call as a disadvantage that we are here facing that. But what if you want to start executing these both of these network calls and get the data simultaneously, so that they will parallelly go and collect the data, and we can see a time reduction in that. So for that we have to launch a separate two coroutines. For that, let us launch separate coroutine for these two requests. So it is possible to launch as nested coroutines, one coroutine inside the another. So that's why we are able to do that. And let's say here we have one data, data one, which will be a string. It will be a nullable string, and we'll assign it as a null. And similar to the data 2, here it will be also nullable string, and we'll collect both the data whatever we got from these network calls in these variables. Okay, sorry, I have to put where, and the same for this one as well. It will change the data and data 2. Okay, now as soon as this we launch this code, this global scope dot launch, this will initialize two variables, and this separate coroutines will start get making the network request individually without waiting for each other. But we also have to collect this in a separate jobs. So let's do that. Job 1 and job 2. Okay, and we'll run a job 1 dot join and job 2 dot join, because if we don't do that, then we will not, our execution compiler will not wait for the results of these two, and our code would directly execute and printing this time taken. So now it will wait for the job 1 and job 2, and then it will simultaneously make the result. So let's clear the log and let's relaunch the app to see the effect. Okay, application has run. Let's go to logcat. And now the time taken has been only 3029, near about 3 seconds, because both of the calls are taking 3 seconds each, and as they both have been started already in their own separate coroutines, so they run parallelly and came up with the final request, and time taken is only 3. So that is the advantage, but the approach to do that whatever we are doing is not so good. We have another alternative for that, and at this place async and await are used. So we'll make some modifications here. We can replace here this launch by async. So this async is very much similar to the launch block, but only it has a difference that the async blocks does not returns the job. Instead it returns a default. Let's make this like this one, and the last line of whatever the will be here in the async block will be returned. Like here get data, it is returning the string function, and if we hover on the job one, we are getting a default of string. This default data type is actually a, uh, it actually a data which we are yet to get, but we know that what data we'll get, but we are yet to get that data, so that is actually a default type. So we can apply this for both of the data 1 and data 2, and we can directly catch the default results into those job 1 and job 2. These are no longer the jobs, these are the default strings, so we can rename those as result 1 and result 2. Okay, and then let's remove these two. Now we can directly log them. This is the use of async, and we can directly log this one as data 1 call 1 result, call 1 result, and this result 1, and we'll do the same. Sorry, call 1. We'll do the same for result 2. Okay, it is here showing some warning because this result 2 is not directly uh, a string. It is as I have just talked, it is a default type, so we have to use here dot await function. So the await will remove the default. Actually it will wait till we get the data, so it till that time it will halt the execution of further coroutine. For it is the same for this one also. We'll attach the dot await function here, and it will only be executed after we get the data. Like just in last video I have given one example that if you have some list of data that, and the data is available on the server, so once we, before getting the data we can't show the elements in the list, so that at that time we have to use this type mechanism. So async await can be used such at such types. So let's try running. If we get the still get the same result. Yes, these are the new results. This is a call 1 result and data 2 data 1. It is call 2 result and data 2, and the time taken is 3018. Well, a bit modification in the time, but the time is near about the same. So that's how we can use async and await functions, and that is the recommended way to use them if we have to perform perform network calls parallelly. So now we have covered all three concepts in this video. First one is coroutine cancellation, second one is run blocking, and third one is async and await functions. I hope they are clear to you. If you have some doubts or some concerns regarding this one, please let me know in the comments. I will try my best to answer this. If you like something in the video, please let me know in the comments. If you don't like something in this video, then also please let me know so that I can improve on my content. So if this video has helped you to clear the concept and grab it quickly, so please click on like, share with your friends and subscribe the channel to help my work and to keep me motivated for further and further videos. Thank you.